In this session, we are going to do some 3 multiple choice questions regarding the topic on odd or even functions. Now, which of the following relations are even? We have Roman 1, Roman 2, and Roman 3. We have y is equal to 2, y is equal to x, and then x squared plus y squared is equal to 1. Which of these relations are even? That's what the question asks us to do. So we shall basically try to identify how these things look like. For example, if you look at y is equal to 2, if I may sketch a graph of y is equal to 2, y is equal to 2 is, maybe this is 1, 2. Y is equal to 2 is more like a straight line. This is straight line, y is equal to 2. Then this other f of x is equal to x, that graph looks like this. F of x is equal to x, or the graph y is equal to x looks like that. This is y is equal to x, and then Roman 3, x squared plus y squared is equal to 1. This is the equation of a circle, so it means that it's going to look like that. It's equation of a circle, and the question is, which one of these is even? Of course, I'm using the graphs to try to figure this out. We said that an even function is symmetrical about the y-axis. Now, if you look at this, it is symmetrical about the y-axis. So, meaning that this one is even. If you look at this, it is not symmetrical about the y-axis, but it is symmetrical about the origin. In other words, if I flipped this or rotated it 180 degrees about the origin, it will look exactly the same. So it means that this one is an odd function. Then if you look at this, you realize that this circle, first of all, it is symmetrical about the y-axis. I mean, if you look at it, it is more like this is it is mirrored this way. It is symmetrical about the y-axis. And also, if I was to rotate this function about the origin, I flip it in the about the origin, like in 180 degrees, you'd find that it will still look the same. So it means that this function is both odd and even, this function. So getting back to the question now, they're asking us which of the following relations are even. Of course, the ones that are really even, we have this one and that one. So the answer there is 1 and 3. Our answer there is D. Then we have another question there still with the same. Which of the following relations are odd? We have y is equal to 2, which is this one. We have y is equal to x, which is right there. Then we have x squared plus y squared is equal to 1, which is that circle. Which one of the following relations are odd? The ones that are odd, we have this one and that one. So the answer here is 2 and 3 are odd. So looking through our objective answers, we have D. Okay, which of the following functions is neither odd nor even? Now let's remind ourselves. First of all, for it to be even, it means that when I plug it negative x right there, it's supposed to give me back the original function. And if it is odd, if I plug in negative x there, it's supposed to give me a negative of the original function. This is the premise we shall be using. So let's analyze part A. Now when you look at A, we are having the input values here. We have 1, we have 4, negative 1, negative 4, 0. So when we put in 1 here, when the value of x is 1, the value of y is 2. So again, when we come and put it negative 1 in the place of x where there was 1, we put it negative 1, we are still getting back 2. So it means that this relation or this function is representing an even function. Another thing that proves this is this. Another thing that proves it is this. This is x. When the value of x is 4, we have 7. Now in the place of 4, when we put a negative 4 here, we are still getting back the same value 7. So it means that A is an even function, so that won't work. Let's go to part B. If you look at the ordered pairs in B, if you look at, for example, when we plug in x, when x is 1, we get 2 as value of y. Now, instead of putting positive 1, when we put negative 1 in the place of x, we are going to end up getting a negative answer in the place of y, negative 2. So this satisfies this condition. This is an odd function. The same can be seen here with 4. When I plug in 4, positive 4, I get positive 7. When I plug in negative 4, I get negative of this, negative 7. So this is an odd function. So B is also not the answer. Let's go to C. If you look at C, we have y is equal to x to the power 3 minus 1. Y is equal to x to the power 3 minus 1. Let's call this f of x. F of x is going to be equal to x to the power 3 minus 1. Now let's plug in a negative x here. So f of negative x, what is it going to give us? F of negative x is going to give us negative x to the power 3 minus 1, and definitely this is going to give us negative x to the power 3 minus 1 as our f of x. Now this does not, it's not giving us this back. This is not consistent with this. This is also not consistent with this. So C is neither odd nor even. So I think that C would be the ultimate answer.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.